interval notation. You have been used to probably doing with Miss Davis what's called set builder notation. She would make you do like bracket X such that X is less than whatever, whatever. We don't do that anymore. We're getting into now calculus style. Calculus is using interval notation quite frequently. And let me explain what that looks like. You will have now be using brackets and then parentheses. Brackets mean including or equal to, whereas parentheses are not included. So remember when you first learned on a number line how to graph, you would do like a closed dot and then an open circle. It's the same kind of concept. Now we're using brackets as including or equal to, and then not included parentheses. So we're going to just do, for the first part of your homework tonight, you just have to write it in interval notation. It'll say set builder also. Don't do it in set builder, just do it in interval, because I just want you to get used to this. Let me write a few up here. And I actually think it's much easier. And then over on this side will be the interval notation. Okay, so it's going to kind of resemble what looks like a coordinate, and sometimes actually you got to be careful. It might be coordinate, but it might be an interval notation if we're talking about some kind of like a domain or range. So you always want to start on the lowest number that X can be. So looking at just this one right here, what is the lowest value that X could be? 3, right? Would you be equal to 3 or including it or not including it? So you would write 3 with a bracket. Then you would put comma. Then what is the highest value that X could be?
4.
Including it or not including it? There you go. This is always on the left side, has to be your lowest number in the interval. Always on the right side has to be the highest number. And what will happen is you guys will switch that on me. Like you might put 4, 3, like depending. So be very careful. I always want low to high. What's the lowest that X could be? What's the highest that X could be? So that was pretty easy. Let's go to this one now. X is less than 11. Here's why. You have to think about this one. What is the lowest value then that X could be? Negative infinity. And that's what you write. Now, infinity symbols are never included. They're always not included. They're always excluded. So we're going to always put a parenthesis around your infinity symbols because it's not really a number, it's a concept. So that's the lowest that it could be. Put a comma. What's the highest value then that X could be? 11. Yeah, so you want to say 10, but you would actually say 11 because you could go all the way up to like 10.9999999, right? But you just put it as an open parenthesis. So negative infinity to 11. That's how you'd write the interval for that one. Lowest to highest. What about this one? What's the lowest value that X could be? Negative 5. Including it or not including it? All the way up to what's the highest that X could be? Positive infinity. All right, and then one more. Now this is a compound one, so we're actually going to create 2. We're going to make it together with a symbol that you should be familiar with. It's called the U symbol. It's a united symbol. So what you do is you kind of ignore this part right here. You work on this first part right here, and you say, okay, if X is less than or equal to negative 2, what is the lowest value that X could be then? Negative infinity. Put a parenthesis around it. And then what would the highest value that it could be? Negative 2 with a bracket, okay? Then you move your hand over. Where you see the word or, you hit unite. Put a U symbol. Meaning I'm going to unite these two parts like of the number line together. Then how would you write this one in interval notation? What's the lowest to what's the highest on just this piece? 3 to infinity. Parentheses, brackets, what do I get? Both parentheses. So that, my friends, is interval notation. How do you feel about that? This is the definition for function. A relation that assigns each element of the domain to exactly one element of the range. But in your algebra processes in the back of your mind, you've been taught several ways to find out if something is a function. Several ways. And I'm going to give you really 3 ways to really describe this definition right here. So if I give you a set of ordered pairs, a bunch of x's and y's, do you remember your teacher saying, oh, make sure that the x's what? Don't repeat. Do you remember that? Like you don't want your x's to repeat? Makes it a function. You don't want your x's to repeat. You do not want 2 x's to have or 2 x's to repeat with 2 different y values. That doesn't make sense in a function, okay? So you might have been given like a set of ordered pairs. You may have been given a graph. And then with last year with Miss Davis, I know for sure you did this. You did what's called the vertical line test. Good job, Brian. The vertical line test. We want to make sure that it passes the vertical line test. That it will also tell us that it's a function. The third thing kind of deals with something new for you, I think. If you have an equation, if you solve it for y, you really should only have one x output, only one x output. And I'm going to show you examples of each one of these because this or no, it's a function or not a function. So here's how you would tell. And you really it's based off of these 3 things that you've learned of in the past. So looking at a table, I just look to see, are any of my x values repeating with different y's? Are any of my x values repeating with different y's? No, that's good. I don't want my x's to repeat. So then, yes, this is a function. The x's don't repeat. Woohoo! Yay! How about this one? Is this a function? No. Why? It fails the vertical line test. The vertical line test says you can only pass through the graph one time. If you pass through the graph more than once, you have failed the vertical line test. So this is not a function. Fails vertical line test. All right, now this one is going to be new for you. Y squared, if you solve this for y, so if I start solving for y squared equals, bring that over, get 2x plus 5, take the square root, and I've tried to teach you this a million times. What do you need to include in front of that square root symbol? Plus or minus. What does that mean? Well, that means if you were to plug in an x right now, like 5, I don't even know, you're going to get out 2 different y's, aren't you? You're going to get out a positive y root and then a negative root y. Would you agree? That's not good. That right there is telling me that you're repeating your x's essentially. This is not a function, that right there. Okay? You don't want to have 2 different y values for one x that you're putting in. So that's an example of where a non-function would come into play. Okay? How do you feel about this? This makes sense to you? Kind of, again, refresher course. All right, good. We're getting somewhere. I've got 3 more things to show you. We've got this. 7, please know that you could also write that as f of x equals 2x plus 7. This is function notation, okay? You've seen it before, you've done it before. Now, you are going to have to do some examples of plugging it in. F of x equals x squared minus 2x minus 8, and they're going to ask you to find the f of negative 3 and the f of a plus 1, something like that, okay? And again, I know you've done this with Miss Davis. Let's just review what to do. What am I asked? This is function notation for f of x. If f of negative 3, what do I do with that negative 3? Plug it in where? Everywhere you see an x. So everywhere you see an x in this function, negative 3 squared minus 2 times negative 3 minus 8. And you get out what that lovely answer is. 9 plus 6 minus 8. 7. So there you go. Easy. If they give you a letter or a quantity, okay, where this is a quantity, guys, this is a binomial, you're going to have to do some extra work here. You still plug it in everywhere you see the x. So watch how I do this. X squared, square this quantity. A plus 1 squared. Minus 2 times x, minus 2 times the quantity. Notice I'm using parentheses for a reason. Minus 8. You are going to have to simplify it because now you're at that higher level of math. I do want everything in a simplified manner. So what does this come out to be? What do you have to do here? FOIL. Yes, Liam.
And I'm going to guess that the answer to the squaring it would be a squared plus 2a plus 1.
Correct. A lot of people tend to think that this is just a squared plus 1. This is a FOILed. Write this down. Make sure you know that. You actually have to do it out on the side of your paper if you don't know the trick. You'd have to do a plus 1 times a plus 1. You'd have to FOIL it out. And you get a trinomial, a squared plus 2a plus 1. Then you distribute minus 2a, minus 2, and then minus 8. And you get this as cleaned up for me as you can without parentheses. So let's see, my final answer would be minus 9? Yes. But function notation, okay? They might give you some very easy, like they might just go, what's the f of c? I see a lot of students are like, what do I do with f of c? You just put c here, wherever you see an x. Whatever they give you, just put it in for x. But sometimes, like if it's a quantity, you're gonna have to FOIL it, all right? So function notation. Guys, we're doing so well. For x values, would you all agree? I know you all know that. Okay, it's really what your x's are allowed to be. Okay. Now, here's what's going to be ironic about how I'm going to teach this. I'm going to teach you what your x values can be. Huh? Yeah, it works. If you are given a fraction, they give you a fraction with x's inside of it. Your denominator in all fractions is not allowed to be what? Do you remember? 0. Okay, that's important. That actually helps us with when we do our domain restrictions, which I'll show you in a minute an example of. Another very infamous one. If they give you a square root or a fourth root, any even roots, if you were to take the square root in your calculator right now of 25, it'd say 5. But if you were to take the square root of negative 25, what would your calculator say? Error. So yeah, it would say undefined error. That even though we call it 5i, Mrs. Seta, we've done this before. Yes, I understand that was in our last chapter. But what's underneath here is not allowed to be a negative. So we have to make that as part of our restrictions. So underneath, we want it to be greater than or equal to 0. So let me give you, like, again, 2 examples of what they're going to say in homework tonight. Find the domain. F of x equals 2 plus x over x squared minus 7x. And f of x equals the square root of 4x minus 1. Okay. So, and I've given you 2 different types. Like, obviously, if it's a polynomial, you don't have domain restriction there. Any polynomial, any line, you can be, any value for x can be anything, right? Any line, any quadratic. But if you have a fraction, we have restrictions, okay? So here's our restriction. The denominator cannot be 0. So here's where it's ironic. You're going to set it equal to 0. But Mrs. Seta, you just said it can't be 0. I know, so set it equal to 0. But you just said it's not 0. I know. Set it equal to 0. Do it my way. Do it my way. Here's why. Factor this out for me. What do you get? I'll tell you, x minus 7. So what are your 2 values for x then?
0 and 7.
Okay, that is what x cannot be. Look at what I just drew. X cannot be 0 and it cannot be 7. It could be anything else it wants to be, but it can't be 0, 7, because if it was 0, it would make the denominator 0. If it was 7, it would make the denominator 0. That's a pain. So how do I write this? One way to write it, you could say all reals, Mrs. Seta, except for 0 or 7. I've seen students write it like that. I'm okay. But I want us to go back to function notation here. If X cannot be 0 or 7, what's the lowest value then that X could be? Smallest value of X? Negative infinity. To where? What's the next smallest? What's the next smallest number that X could be?
0.
To 0. United with? Think of a number line. Where's the next value that X could be? It can't be 0 and it can't be 7. It can be everywhere but not 0 and 7. So how would you now write the next piece?
1 to 6.
I know, that's what everybody always says. Well, 1 to 6. Well, actually, no, you write this. You write 0 to 7 with parentheses, excuse me. You're saying not including, meaning I can get really, really close to 0, but I can't be 0. So that's why we put those parentheses. But wait, there's one more section. What's the last section I'm not thinking of?
7 to infinity.
Very good. So this would be another way to write the domain. You could say all reals except 0, 7, which I'm sure a lot of you are going to say it like that because you're like, that just seems easy, Mrs. Seta. And that, just write that. So Mrs. Seta, this is another question. Everybody's like, Mrs. Seta, I don't have to worry about the top. No, you don't have to worry about the top. Your domain in a fraction is restricted on the bottom. There's some restrictions there. All right, if I give you a square root symbol, if underneath a square root, underneath needs to be greater than or equal to 0 is what I wrote up here in your notes. So let's do that. Whatever's underneath, 4x minus 1, just write it greater than or equal to 0. Solve for x. This one's even easier. X is greater than or equal to 1/4. Somebody want to write that in notation for me? What is the smallest value that X could be if X is greater than or equal to 1/4? What is the smallest? 1/4. Do I include it or not include it? Include it. What's the highest value then that X could be? Infinity. Okay? Whew. And yet one more. And you're all get it. But they're really not that hard. I mean, when you start to graph it, you're going to look and be like, okay, this is a parabola that's been shifted. This is a line. This is a line. And so then you got to visualize that. But what I'm asking you to do right now is I'm asking you to plug in f of -10. So here's what I want you to understand. They're going to give you the function piece on this side, on the left. Then on the right, where they have the comma, sometimes they have like a semicolon. This right here is the domain for that piece. So listen to what I'm saying. The first piece, this first one up here, can only have a domain of x being less than -3. The middle piece only has a domain where x is between -3 and 7. The last piece only has a domain of where x is greater than or equal to 7. So looking at this first problem, f of -10, which piece, top, middle, or bottom, are you going to plug in -10? Which piece?
Top.
Why the top?
It's less than -3.
Is it -10 less than -3? Okay. So then what you do is you ignore these two pieces right here. I can do that? Yes. You're only going to put it where it's restricted. -10 is less than -3. So you're going to put -10 in for x onto that piece. So into the top, I'm going to put -10, square it, and add 1. What does that make? 101? That's your answer. Done. That's it. I don't know. You tell me. You want to do it again? Great. Let's go. Where would I put 11? Top, middle, or bottom?
Bottom.
Why the bottom?
Greater than 7.
Okay, don't look at this side. You're putting in 11 and determining which one you're using. 11, is that less than -3? No. Is 11 between -3 and 7? No. 11 is greater. Oh, it's in the bottom one. So I am going to plug 11 in for x onto this function part. Now, this doesn't make sense to some of you There's nowhere to plug in x. So then what is your y value? 12. That's it. It says no matter if x is bigger than 7, your answer is always 12. That's what that says. If your x value is bigger than 7, which this is, your answer is always 12. All right, let's do one more. F of 0. Top, middle, bottom. Why the middle? It's in between -3 and 7. So much easier. Oh, okay, so if it's this one, so then I plug in my 0 in here. So what's 2 times 0 minus 5? There you go. That's a piecewise function. It's learning which piece to plug it in.